All right. To decide if it's a chemical or physical reaction, you'll have to look at the observations here. Generally, if there are color changes or like in this case, your two things are changing colors, that one indicates there's something happening. Um, and then formation of gas, definitely there should be a chemical reaction to form the gas over here. Temperature increases probably a result of the chemical reaction that formed this gas here. So you can kind of read through over here, and the introduction section of this lab will describe to you more on how to determine if it's a chemical or physical reaction. When it's a physical reaction, we can actually write no reaction NR for our answers for the chemical equations. So if it's a chemical reaction, we will have to write whatever is happening in the reaction. So for example here, if you take magnesium and hydrochloric acid to mix together, and it says you form a gas and the temperature goes up really high. At first, the metal was shiny silver and then there's no color, but they don't observe any color changes. But the fact that there's gas here tells me this is a chemical reaction. In fact, for step A, for assignment A, basically I have magnesium and I have mixed it with hydrochloric acid, and it's actually creating some gas. What is this gas that's being created? When there is a chemical equation, you tend to switch up the positive charges, okay? So basically magnesium is going to trade place with hydrogen. They're just going to trade places here. So hydrogen will be kicked out, and hydrogen cannot exist by itself. It actually comes out in H2 hydrogen gas form, and this is the gas you observe coming out. And what results is, therefore, you have magnesium and has to pair with chlorine. Now, if you take a look at magnesium and chlorine, magnesium is in group 2 of the periodic table, so it will be a +2 charge. And chlorine is in group 7, it will have a -1 charge. If you have a +2 charge, so magnesium is +2 and chlorine is -1, we'll need 2 chlorines to balance with 1 magnesium. So therefore, my formula here will be MgCl2. If there's 2 chlorines, I put a little 2 behind the chlorine. That indicates that the chlorine has 2 units in there. And then the next thing you want to do is make sure the equation is balanced overall. Both sides need to have the same amount of H, same amount of Mg, same amount of Cl. Now obviously you have 2 Cl here, so you need to fix this side to make sure you have 2 by putting a big 2 next to this whole compound. So therefore you have 2 chlorine here. Because H and Cl is +1 and -1, you can't have HCl2. You have to put 2 in front of the HCl compound, which works out great because you need 2 hydrogens on this side. So 2 hydrogen, 2 chlorine, 2 hydrogen, 2 chlorine. Magnesium is 1 and 1. So both sides are now balanced, okay? So let's take a look at B. B tells us there is some sort of chemical equation happening because there's black stuff forming and the solution is changing color. So a lot of things are happening. In fact, this is what happens when you have zinc mixing with copper sulfate. Okay, in this case here, again, these two will change. The positive guys will just switch places. And in this case, zinc, when it turns into ion, is +2 charge. Copper, when it turns to ion, is +2 charge. Sulfate ion here is -2 charge. So it's perfectly balanced. Everybody is 2 and 2. 2 plus can balance with 2 negative without having to have those extra numbers on the side there. So basically what I can write is basically, oh, therefore copper is coming off, and then you have zinc and sulfate paired up together. So basically, the copper sulfate is a blue color solution. Over time, as the copper turns into copper solid, that's the black stuff you see forming. The blue color fades because the blue form is changing into the solid form right here. So, and in exchange, the zinc is going to take place with the zinc sulfate, and this solution is colorless. So it looks like the blue solution is fading because of the copper sulfate going lower to make more copper solid here. Okay, so this is how you look at chemical equations. Now we always want to double check, make sure both sides have the same amount of zinc, both sides have the same amount of copper, both sides have the same amount of sulfate. In this case, it works. So for the rest of them, it should be pretty simple. You can follow just making sure both sides have the same number of compounds or elements, okay? What's unique is with D and E, when they have precipitate here, I'm going to help you guys out a little bit with the precipitate formula. So obviously, if there's a precipitate, it tells you there's a reaction happening because you're forming a new product. Precipitate means the solid is coming out, okay? So they're making blue powder here, and this one's making a light blue powder. So it's kind of cool. So in this case here, CuSO4 plus NaHCO3. NaHCO3, this is sodium bicarbonate. That's actually just simply baking soda. So it's just taking the baking soda, put it in some water, and you have a solution of baking soda. This is copper sulfate. Copper sulfate can actually be found in some stores like Home Depot, but we definitely don't want to use this for fun. Baking soda you can use at home for cooking, for cleaning, all kinds of stuff. All right, so we have this here. We make a precipitate. So the precipitate that you formed as the blue powder is actually this guy, CuCO3, copper 2 carbonate. Okay, so in this case here, we know this is one of the products. And then the other product, so if you notice, we're basically just switching that and that, okay? So the other product that you get is actually going to be NaHSO4. Now, I'm not going to balance it out for you, but your job is to make sure both sides have equal amounts of copper, equal amounts of carbonate, equal amounts of NaH and SO4. Okay, so just double check to make sure both are the same. I'll do the same for line E. You have a full precipitate, formation of precipitate, and this time is light blue powder. This is really, really pretty. Like you see light blue powder and a dark blue liquid. So over here, you have CuSO4 plus NH4OH. Now this has a bunch of polyatomic ions, so it's a little bit different, but you will have to memorize polyatomic ions when you go to later chapters in your Chem 1 lecture. So copper and this guy is ammonium. They will be trading places now. Ammonium is +1 charge. So this is the ion. It looks like this, +1, and this hydroxide is a -1 charge. Copper in this case is a 2 charge positive. Sulfate is a 2 negative charge. So what we do is we will be switching them around. Like these two are going to trade places. So ammonium is going to pair with sulfate. Copper is going to pair with hydroxide. So what you get here is Cu. Now copper and hydroxide, you need 2+, and this is -1. So you need 2 hydroxides. So that's why I put a bracket around the 2 and say, okay, now I have 2. The reason why I put a bracket here is if I don't put a bracket around here, it could look like there's 2 hydrogen and just 1 oxygen. Hydroxide should come in a pair here. And we know that Cl, in this case here, I didn't put a bracket because Cl is 1 element. There's no element that's L by itself, so it's not misleading that way. But there's an element H by itself. So we have to make sure we put a bracket around the OH, so we signify that there's 2 OH here to pair with 1 copper. And then what's left over is you have NH4. NH4 is +1, sulfate is -2. So you want to make sure you put 2 of these guys there. So because you can't just put 2 next to it, it will look like NH42, which is really wrong. So you put a bracket around this and say there's 2 of these guys paired with a sulfate. So that's how we would balance it. Now, and then your job, the next part is to make sure there's the same number of copper, same number of sulfate, same number of ammonium, same number of hydroxide. Obviously, this isn't the same. So you'll have to put some other coefficients in the front here for this guy. Okay? So that's kind of basically how you work on it. Now, there are going to be some that are physical reactions here. So physical change, and you don't have to write a chemical equation. In that case, you would just write NR. NR is for physical changes. Okay? All right. I hope this helps.